Hi, folks. We're going to get off onto a little mini series here about statistics, which is important to an engineer because we need to know if something's meeting spec or not, or if it's not, how far off is something, and does that make what we're designing work correctly? Um, and we use numbers to find that out. So, statistics does a lot of different things. It can tell us what's true or not true. So, for example, you might have a parent say that, it's more dangerous out there for you to walk down the street than it was when they were your age. And that may or may not be true, but you'd have to go look up at the statistics for violent crime committed in the area per capita and things like that to know whether or not that is the case. So, statistics can tell us a lot of different things. It can tell us about temperatures, and it can tell us about labor and what's happening in the market. It can tell us about economics and all sorts of things. We're going to be looking at it from a quality control perspective. Um, is what we're designing meeting our criteria in order to make that work? Now, for this, you're going to need your workbook that we were working on a while ago. We're going to start on page 63. Um, and I know we haven't used it for a while, so go find it, please, so that we can use that. If for some reason you can't find it, if you go to Google Classroom and you go into your classwork, yours might look a little different than mine, but there is a links and resources tab that you can go to. And somewhere within there is the IED workbook. It's a PDF version of the book, and you can print from that. And if you don't have either one of those things because you lost it or whatever, then you can draw this out on paper, or worst case scenario, go back to the school and get yourself another workbook. All right, so here we go. We're going to talk a little bit about statistics and what they mean and what they do for us, and then we will go back and do some writing things down and taking some notes starting on page 63 of the workbook, or your printed out sheets, or you're just writing it on notebook paper. All right, here we go. So statistics is a way of dealing with data. It's really important for us to be able to do this. If you have a job that you're making any kind of money in, you're probably going to have to look at some data and what's happening with those numbers. So this can tell us and help us with the quality of the design process. So statistics deals with central tendency. That means that things, if you take a whole bunch of Cheerios and you weigh them with a really good scale that can weigh a Cheerio down to maybe a hundredth of a gram, you will find that most of them tend to be around the middle of a range of values, right? That means that things tend to be towards a central tendency. If you put 1,000 people in a room and you measure their height, they will all tend to be towards one middle height, whatever that is, 5'6" maybe. So those are the measures of central tendency. And let's go ahead and write those down. And those are the mean, the median, and we'll come back and we will make sure we know what these mean in a little bit, and the mode. Okay, so we will understand. We'll define those. Whoa, my camera is going out of focus. Come on, go focus again. Now I'll come back to that in just a moment. All right, mean, median, and mode. There's variation around the center or around that middle point that we call a range. Standard deviation we'll talk about, and interquartile range, which we actually dealt with way back in first semester when we were dealing with the carnival game. But we won't be looking at that now. And a distribution, it means how are the values distributed around the middle. And we can show that by the use of frequency tables. We'll be making a histogram, and we are going to talk about what a normal distribution of values means. All right, so Rather than write that down, let's go ahead and take a look at this. Now, mean is the same thing basically as average, except average is a general term and mean is a mathematical term. Okay, so the mean is the sum. Now, before you get scared of equations that look like this and you go, oh my God, I'm out, I can't do math. If you knew what this means to add up. So this funny looking E means sum. So it's the sum. X is an individual value. I means each individual value. So if you knew what each individual value is, could you add them all up? I hope so. Could you then divide by the total number, which is what n is, of them? Okay, good. Then you will find the mean. That is what that little symbol means. So don't be scared of those things just because you're not familiar with it. You'll be able to do fine with this stuff. All right. So this is, now you can go ahead and write these things down if you would like that are in your notebook as we go along. So let's go ahead and do that. I'm going to write along with you. So that little weird U stands for the mean. Okay. The weird looking E means sum or add up. Sum or add up. The XI means an individual geez, I can't spell individual data point or data value. I'm going to put an individual data point. And N means total number of values. All right. So we've written this all down. Now we can talk about what the mean is. So let's go ahead and write this down. The mean is AKA average of a data set. We're going to get into median and mode in just a moment. Okay, so that gets us the mean. So let's say we have all of these values. I don't know what these means. Then these are the numbers of M&Ms that came in the bag. Okay. If we add up all the values, we get this. The total number of values that there are is 11. So we added all of them up, got this number, n is 11. We end up with this value. Now, rounding matters. We're going to talk about that in just a moment. So first of all, whenever you're dealing with a lot of data and multiplying, adding, subtracting, it's a general rule that we don't round until the end. Okay. Those interim values, this is really important in things like chemistry and accounting, right? Where you don't want to be off. You don't round until you get to the end. That's why using 3.14 for pi instead of the pi button on the calculator is not going to be as accurate. So we're going to round to one more decimal place than the original data. That's going to be really important. We'll do the same thing for the standard deviation. So if we ended up with 22.09, how many decimal places are there in the original data set? Well, there's none. Okay, so we're going to go to one more decimal place than the data set, which means we're going to end up with a mean of 22.1. Okay, we will talk about that as we go along, but that is important. All right, now the next thing we're going to talk about is the mode. The mode I don't find as valuable, and most statistics teachers will not find this as too valuable, but we need to know what it is. Anyway, it's the most frequently occurring number. So let's go ahead and write that down. The median is most frequently occurring. I think there's two R's in occurring. number in number, and then we can put in parentheses a little s because sometimes there's more than one in a data set. Oops, I put that in the wrong spot, folks. I'm going to switch these. Sorry about that. And then we'll go like this. Whoops. So if you draw those little arrows, we're okay. You probably were saying, what are you doing, Clat? All right. So the mode is the most frequently occurring value. So let's say we have this. 21 occurs twice. No other one occurs. So we're going to call that 21. Okay. If there are two numbers that occur with equal frequency, we call that bimodal. And then if there's more than two, we call that multimodal. So here's an example of we've got the mode. Here there are two numbers that occur with equal frequency. We call that bimodal. And the other one has several, and we will call that multimodal. Okay. Honestly, we're not going to deal with mode too much. Now, median is important. It is a measure of central tendency. The median is the value that occurs in the middle of a data set. Let's write that down. So the median is the middle value in a data set. All right. So, sorry, I mixed those two up. Okay. Now, why is this important? Isn't that kind of like the mean? Well, it could be, but it might not be. So, if we take a data set like this, and we put them into order, it's going to be the one that's right in the middle. Okay. So this number is right in the middle. There are 5 on each side. Now, what happens if you have one that's even numbered, though, like this? Then you'd take the 2 in the middle and average them, and that would give you what your mode is, or your median is. Now, why is it important that we have the median and the mode, or the median and the mean? Here's the difference, and I had somebody tell me this story once, and that it was perfect. I believe that it was 1990 is the year. I might have the story a little bit off, but the average income of a graduate of from North Carolina University who got a degree in geology in 1990, the average income for that person is in the tens of millions of dollars a year. Okay, I'm going to say it again. The average earnings per year from a graduate in the field of geology from North Carolina University in 1990 is multiple millions of dollars a year. Now, you're thinking, I'm going to go to North Carolina University, get me a geology degree, right? Well, here's the problem. There were 10 graduates in geology that year, and one of them was Michael Jordan. Okay, so you can see why the average may not be telling you the whole story. Now, if you put the median in there, that's going to be more realistic that it's, $80,000 or something, which, is still good, but it's not representative. So that's what the median will tell you. If you want to know what the average American makes, you want to find the median, because the people the 1% that hold all that wealth that you hear about skew the average, right? It makes it look like people are making a lot more money than they really are. So that matters in some cases. All right, let's move on and talk about now some measures of variation. So we've got the range. The range is pretty simple. It's the biggest value minus the lowest value is the range. So in this case, it's got a range of 41. Let's go ahead and write that down here. Let's write range is highest minus lowest value. All right. And that just tells us the range of values that we're dealing with. Now the next thing is the standard deviation. The standard deviation is, whoa, look at this thing. Don't run away. Okay. Don't worry. We just said, did we already figure out how to find the mean? So we know what that is. Do we know how to count? Yes, we can get what the number is. Could we take each individual value minus what the mean is, add them all up and square each one of them? Cool. Can you hit square root on your calculator? Yes, then you can find out what standard deviation is. Okay. So standard deviation is a way of finding out how far do we get from the middle and still kind of be where most of the data is. And this is a formula to find that. So let's go ahead and bring our, let's go ahead and put this in, and we'll put our second one is standard deviation. Okay, and this little symbol is the symbol for, I'm going to let you cheat a little bit and just draw an arrow to, it's a symbol for is the symbol for standard deviation. And here's the formula again for that. All right, let's get back into this. Now this is going to go through and talk about how we find this out. Again, you don't round until the end. So how do we do this? We find the mean, which we did. Then we add up each individual value minus the mean and square it for each and every one. Okay. Then we're going to add all of those up. Okay, we're going to divide by the total number that there are. See, I told you it's not that hard to do. It's just a little tedious. And finally, we take the square root of that and we end up with a number. Now, again, rounding is important. Okay, we're going to go, whoops, I'm going to go back to that. We're going to round to one more decimal place past the original, what the original data set had in it. All right, now let's talk about distribution of data and how we can show that. Okay, there are a couple of ways of doing that. And one of them, we're going to talk about a histogram. And the other one is a dot plot. How do we see that data is distributed? Okay, so a histogram is basically where we take values and we show how many of them there are within a certain range. This slide is kind of not that great because it's only showing a big range of values, and it's only showing a few. It doesn't really show us a lot, so I'm going to kind of blast through this slide. So here's how it works. We create kind of bins, right, to hold certain values. So how many are between 1 and 5? How many are between 6 and 10? And how many are between 11 and 15? And this is assuming that down here is the lowest of your range and up here is the highest of your range. We plot those out with how many times each one occurred, and it gives you a visual representation. Now, this is a little bit better representation of what this looks like. This is a measurement of what's supposed to be a 3/4 by 3/4 by 3/4 cube, and we're measuring the one specific side of this to see how well close does the manufacturer get to that target of 0.750. And most of them do show up right in the middle, but then there are some that are a little bit off. They get a little bit bigger, a little bit smaller, because you can't get wood perfect, right? It even expands and contracts with moisture. So this is a good visual showing us how this is going to look when we plot out our data. All right, so we have maximum and a minimum, and we're seeing kind of how many are in between. This is another way of plotting things out. we're using a dot plot. This is my favorite graph because I get to like shoot lasers. Okay. And it comes up with a similar sort of pattern. Now, if we have what's called a normal distribution, and you may have heard of the bell curve, what happens is that your data, if you drew a line across the top of it, looks like a bell. So normally it's a little bit steeper. I mean, think of the Liberty Bell, right? It's kind of got a big hump in the middle, then it comes down, and then it kind of flares out on the side for some of these. So think about the height of people, right? Most people are in an average height. And if you get taller and taller until you get over here to, NBA centers are going to be way over here. They're very rare, right? Somebody who's 4'6" is going to be way down here because they're pretty rare. And everybody else is sort of in the middle. And this is what it's going to look like. So let's go to here and say data is considered normal if it looks like a bell curve when distributed. And let's draw a little picture of what that's going to look like. So it kind of goes up sort of steep, makes a curve like this, and then it comes down like that. Okay. With your mean, let's go ahead and draw this and make that little symbol, that funny looking U with the long tail on that side. All right. Now we're going to come back to this later on when we talk about the empirical rule, but I'm not going to do that right now. All right, let's see what we can do with some of this data. And here's the sitch. We've got a part of manufacturing quality control testing for a toy is to measure the depth of a connector piece that must fit into another part. The designed depth is 4.1 centimeters. That means what it's supposed to be. Every 10th part is measured. The following data was collected during a 2-minute production period for quality control. See if we've got it the way we want it to be. Okay, so first of all, this is our measurements. So one of the things we're going to need to do, and especially to find the mode, is to put that in order. So let's go ahead and do that, and we're going to kind of kill two birds with one stone here. Let's go ahead and put it in this chart down here for each individual value. Now, be careful. Let's look at what's our lowest value here is 3.8, it looks like. And our highest value is 4.4. So we're going to write all these down in order, and don't skip ones that are repeated. We need to write those down, and let's cross them off as we go along. So it's 3.8. There's a 3.9 and another 3.9. And go ahead and continue this chart. Pause if you'd like. And by the time we're done, you should have this list in this order down here. All right, now we're going to do some work to find some of these things. First of all, we're going to find the mean. Let's remember what our formula for the mean is. Our mean, weird looking U, is the sum, weird looking E, of all of the individual values divided by the total number of values that there are. Now it really should be a lowercase n, so I'm going to put n right there. Let's go ahead and substitute where it's mean equals. We'll add all of these up in just a second. Divided by 2, 4, 6, 8, 10. There are 12 values. So you're going to add all of these up and divide them by 12 to get us to the mean. Don't forget to report to the right number of decimal places per the rules we just talked about. Pause. And you should have ended up with 48.8 when you added all of those up. Now, when you divide 48 by 0.8 by 12, it's 4.066666 on and on and on forever. But remember, the rule is we're rounding to one more decimal point than our data set has. Our data set has 1, so we're going to go to 2. So that would be rounded to 4.07. If you wrote down 6, I don't know why. Students always want to write down round 4.066 to 4.06. 6 rounds up, folks. So, all right. So we've got our mean. Let's find our median. What's the definition of the median? It's the middle number, right? So what's our middle number? Well, if we've got 2, 4, 6, and 2, 4, 6, it would be in between 4.0 and 4.1. If we average those, add up 4.0 and 4.1 divided by 2, our median would be 4.05. And our mode is the most frequently occurring number. Okay, let's write that down. Our mode was most frequently occurring. And don't get mad at me if there's not 2 R's in occurring. I'm pretty sure there are. And 2 C's. Might need to look that up. Our most frequently occurring number is both 4.0 and 4.1 both show up 3 times. So we're going to write both of those down. 4.0 and 4.1. And remember, we call that bimodal. All right. Now, the last thing we'll do in this session is we're going to find the standard deviation, and we'll talk about what that means and why we need it after that point. So what we're going to do is we're going to take each individual value and subtract the mean. Now, if we were doing this the right way, we would keep all of those decimal places in the mean, because remember, you keep them. But for the purpose of expediency, we'll just use this 4.07. Okay. And then you square that number and put that here. So some of these numbers over here will be negative, and some of them will be positive, because when you subtract the average from the lowest, you're going to get a negative number. And when you subtract it from the highest, you'll get a positive number. These will all be positive, because when you square a negative number, it becomes positive. A negative times a negative is a positive, right? So go ahead and do them across, and notice when you get to 3.9, let's not be silly and do it twice. You just copy the number, right? So you actually don't have to do this that many times. So in my calculator, I'm going to put 3.8 minus the mean, which is 4.07, equals, and I'm going to write that down, which is a negative 0.27. Negative 0.27. And then I'm going to just, while I've got my calculator here, I'm going to square that number. So you should have something on your calculator. Now, we want to keep as many decimal places as you're willing to write. So if it's only giving you a few decimal places, write all of them down. I'll do one more, and then you've got to do the rest. So, okay, so now it's 3.9 minus 4.07. Okay, I'm going to write down what that is. That is a negative 0.17. Square that number. Yours might have a different way of squaring it, but most calculators will have that. And that is 0.0289. All right. Now, I'm not going to go redo that. I have 3.9 again. Let's just copy down that number again. All right. And you're going to go through and do all of those all the way down, copying when you can. All right. Pause it and do it. Now, just in case this happens to you, where you square a number and your calculator says something like this, it's 9 exponent to the -4. What that means is it's a 9 when you move the decimal place 4 spaces to the left because it's a negative exponent. So if that happens to you, you can just say, well, it's a 9. The decimal place would be here, and it's going to go 1, 2, 3, 4. So it'll be 0.0009 in this case. So it looks like everything's going to have 4 decimal places. So if that happens to you, that's how to do it. All right. All right. So in our standard, in our formula, we already got our mean, each value minus the mean, and then squared it. And now we're going to get the sum of all of the individual values minus the mean square. So we're going to add all of these up in your calculator and get the answer right here. Come on, do it. I'll pause. All right, and we're almost done here. So we should have ended up with 0.3268 down here. If you didn't get it, it's easy to miss one, but that is our added up value. Now our range is not related to standard deviation, but let's put that in here anyway. It's 4.4 is our highest value minus 3.8 is our lowest value for a total of 0.6 of a difference between the highest and lowest. All right, so that's our range. Now, our standard deviation. Let's go ahead and zoom in just a little bit here. There we go. And we will now go ahead and solve for this. So here's our formula. Now, let's substitute. We're going to go this is the symbol. We're going to do the square root of, actually, I guess I could have written that right there. That's not what I meant to do. I'm going to erase that. I hope you're using a pencil. If not, if you wrote right there, where we meant to substitute is down here, okay? And we've got a lot of room. So we're substituting, we're going to take the square root of the sum of all of those individual values. Now we have it. Here it is. Okay, so this is 0.3268, and we're going to divide that by the whole number that there is and take the square root of it, and then we're going to remember to report to the correct number of decimal places. All right, so here we go. Let's go ahead and do this. Come on, focus. There we go. All right, so we're going to do 0.3268 divided by 12. Okay, and that's going to get us a number. And then for me, I think on here I have to use a function. Somehow, every calculator is different. So for me, it's the function, and I'm going to push square root here of my answer. Which is again here. Different calculators will do this a different way. You might have to plug this in, and that's going to get us a 0.165. Now remember that we are rounding to one more decimal place than our original data set that had 1, so we're going to round to 2, which would be our standard deviation is 0.17. All right. Good enough for one day. Please take a picture of this, of your notes page and of this page. Turn them in, and we will talk about how to set up a histogram next class. See you then.